Hello, my name is Stepp. I'm with Stepp Manufacturing. I'm here today to do the training on an OJK 125 machine that's located behind me. We'll be doing the operation and some of the maintenance training on this thing today. So we're going to dive right into it. We're going to start at the front of the machine, kind of work our way back, and we'll fire it up and show you how to operate everything and go from there. Alright, we're going to start at the front of the unit and kind of work our way back. We're going to start with the hitch. It does have an adjustable hitch on it, so you can change the hitch height for different vehicles. It's a 2-inch ball hitch equipped on this unit. They also do come with pintle hitches if you're so inclined. The unit does have safety chains on it. They are graded and stamped chains, so if you ever have to do a DOT inspection on the trailer, you've got that. The chains are connected with some eye bolts. The next thing that we've got here is our light connector plug. This is to operate our tail lights and our brake lights and our running lights on the unit. Make sure you get that plugged into the towing vehicle. The next important thing on the trailer, this is the safety device, is actually the breakaway. It's located here. You want to make sure you hook this to the towing vehicle. That safety breakaway will lock up the brakes in the event of a disconnection from the towing vehicle. So that's a safety device. It's required by the DOT that we have that on there. So if the trailer comes unhooked from the trailer, it's going to pull that out. So that's located right here. Just hook it on to your truck somewhere with a clevis type hook. Just going to kind of keep working our way back. The next thing you've got is a 25-gallon fuel tank. The unit is a single fuel source. It uses diesel. Either number 1, number 2, or a blended fuel. In the colder weather and the colder climates, they'll run a blended fuel in the colder weather. But just regular number 2 diesel fuel will work in here. The diesel tank is going to supply both the engine and the burner system for the tank. So, it's a good idea. You've got plenty enough fuel there to run, a 12, maybe even a 14-hour shift. Make sure you top it off every morning before you start. If you do run out of fuel, you have to bleed the engine and also the burner to get the air out of the system. There is a manual sight gauge here to check your fuel levels, and then you've got a couple of lines that come off. One of them is for the diesel burner, one of them is for the engine, and one of them is just a return line. So that's the fuel tank. On the back of the fuel tank, actually it's back on the cross member, there is a fuel filter for the burner system, and we'll get you a good shot of that so you can see that's one of the maintenance items. It's the fuel filter. The engine also has its own fuel filter, and we'll show you that in a minute also. On the front of the engine, obviously we've got a 12.5 horsepower Kubota diesel engine that runs our hydraulic system and also maintains our power. You've actually got 2 alternators on the system. This big alternator that we see here runs the heating system in the hose. There's actually heating elements inside of the hose to remelt and soften the product in the hose so that you can get the flow established. This big alternator here is actually a 24-volt alternator. It's going to push out about 26, 27 volts to the heated hose system, the elements in the hose. The engine also has its own small 12-volt alternator that maintains the battery that runs our burner system, and it also starts our engine. The radiator on the engine takes regular glycol type antifreeze. There's an overflow jug on the side also. You just want to check and maintain your level of antifreeze. We're gonna move the camera here and get some different shots of the engine so you can I can point out some of the maintenance and operational stuff there. On our engine, on the top of the engine, we have our control panel. You do have a cap here to get at the engine fill, which is located underneath the engine here. The dipstick on this particular unit is on the other side of the engine, and we'll show you that in a minute. Our fuel filter for our engine is here. It does have a service valve, so you can turn the valve off when you change the filter so you don't drain all the fuel out of the system. The tank also has a service valve for the burner filter, so you can change that burner filter. The burner filter is located just down here, and to change that, there's just a bolt on the bottom. You take the bolt out, and the filter actually comes out of the inside of it. To start and operate this engine, you actually turn the key backwards until the glow plug light goes out. It has a glow plug heating system in there to warm those glow plugs up before we start it. This is really crucial in the cold weather environments. This is a pretty good running little engine, pretty good starting engine until we get into that 10 to 15 degrees Fahrenheit range. Like I said, it's a 12.5 horsepower Kubota 2-cylinder engine. The air filter is located right here on the back of the engine, and then the main job of this engine is to power the hydraulic system. That's what we're seeing direct coupled here is an Eaton pump on here to run both the mixer and the pump on the main tank. Like I said before, the other thing this engine does is supply power for the hose system, and then also supplies power for the battery system on here so that the burner system works. One of the things that we tell you to do on a new engine, we like to see you change the oil in the first 40 to 50 hours. And then after that, it's 100 hours on oil changes. When you do oil changes, check your belt tightness. You got 3 belts on the unit, 2 that run the big alternator, 1 that runs the small alternator and the fan. So those are some maintenance points there. When you change the oil, just make sure your belts are tight. If you notice that your hose starts to heat slowly, you know, it's heating up, but it's just taking longer than it usually does, it's probably needs the belts tightened, because if the belts are loose, we actually lose some horsepower going to that alternator. So again, we've got a set of dummy lights here. One of them is your glow plug light. You actually turn the key backwards till the glow plug light goes out. The other lights are if it's over temp, if the alternator quits working, or if we have low oil pressure, the light's going to come on. Pretty self-explanatory, pretty simple little engine. You know, if you do run out of fuel, you do have to crack the injector lines and bleed the air out of it to get it started. We're going to kind of go over the burner system. We'll get another shot of the other side of the engine so I can show you the dipstick so you can check oil levels. Then we're going to go over some of the burner functions and maintenance stuff. The dipstick's located right underneath the fuel shutoff solenoid. It's right here. Check your oil. We're going to roll around the other side of the engine and show you the other stuff, what's going on there. On this side of the engine, you have your oil filter, your 12-volt alternator, and also your starter. Everything's located here. You can see the antifreeze overflow jug down below. Your battery is located in the battery box here. It's just a Group 24 deep cycle automotive type battery. There's nothing special about the battery. Behind that is our burner system. The burner is actually what heats our product up. We're going to kind of zoom in on some of the features and items on here so you can kind of see, you know, some of the adjustments. The burner is set from the factory to run very efficient. If you guys notice when you're operating and it starts to smoke, we either need a burner adjustment or we need to replace some of the consumable parts like nozzles and nose cones on the burner. This burner should burn for 500 to 1,000 hours before we need to do anything with nozzles and stuff like that. But depending on the climate, you may have to adjust your burner to get it to fire clean. It's kind of like an internal combustion engine. We have to have the right air fuel mixture to get that burner system to burn clean. So we're going to kind of show you some of the things here on how to adjust the burner if you have to. Most of the time, if you see a good clean burning burner, we're not going to screw around with it. If we close the air off too much or open it up too much, we're going to run into either burner firing issues or it's going to smoke real bad. So you want a good clean burn out of the burner system. We'll fire that up here in a minute so you can kind of see how that works. This is our burner system here. This is a 12-volt forced air Beckett diesel burner. It's very similar to a burner that you would have in a household furnace, other than the fact that it's 12-volt. The 12-volt is obviously an automotive type setup. So it's got 12-volt controls, a 12-volt motor, and you know, so it's really designed to run off the battery and the engine system here. The burner's made up of a handful of different components. The big shiny thing that we're seeing over here, that's actually the motor. The motor's connected to the fan. The fan's located in the main housing of the burner. And then that motor also connects to the fuel pump. So when we flip our switch on the back to turn the burner on, that motor kicks on, starts the fan, starts the fuel pump. When our thermostat calls for heat, this primary control, which is the main brain box of the burner, tells the black box here to send spark down there. This is actually our ignition transformer here. This sends the spark to light the burner. Once the burner establishes a flame, there's actually a flame detection device inside of that. It's called the photo eye. It's actually located on the top of this, you know, on the top of this black transformer. Once it sees that it has established a good flame, it's going to light and stay lit. If it doesn't light, it's going to try for reignition, and if it doesn't light the second time, it's actually going to go into a lockout mode. Now, reasons it wouldn't fire, one of them would be if it's out of fuel. One of them if it had an air bubble trapped inside the fuel pump. If there was no spark or no power. Those are all things that are going to tell this thing to lock itself out. If the burner goes into a lockout mode, we have to manually turn the power switch off in the back and turn it back on to recycle the burner. If you try to do that 2 or 3 times and the burner's still not kicking on, we got to start doing some troubleshooting on the burner. The burners are a very simple device to work on, very simple to operate. They're very durable. You know, and a couple of the main things that cause burner problems, one of them is no voltage, you know, just no power or low power. The other one is no fuel. So we always diagnose those problems first. Let's check to make sure we got power to the burner. Let's check to make sure we got fuel. Now on the bottom side of the burner, to check to see if we have fuel, there's actually a pit cock. We can open that up and it's going to spit and sputter fuel out. Now if it's spitting and sputtering, it means we've got air trapped in the system. So we have to, you know, get that air out. So you have to bleed the burner. If you ever run it out of fuel, that's what you'll have to do. You'll have to open the pit cock, turn the switch on, and you may have to cycle it 2 or 3 times until you get a good steady stream of fuel out of there. And then usually you close the pit cock and the burner takes right off. Now, located right next to that is we've got our air adjustment. There's actually 2 air adjustments on this. The one big screw here, this does our fine air, and that's the side plate. That's going to rotate side to side. That's going to be our fine air adjustment. The screw here in this band is our large air adjustment. So we'll loosen that screw and adjust that up. Now, if you're noticing that your burner is smoking, you're getting a lot of black smoke out of it, it's because it's got more fuel than it's got air, so we got to give it a little bit more air. If the burner's not lighting, you know, you can hear it hiss, you can hear the spark igniters hiss, you can, you know, you've checked, you've got fuel and it's just not lighting. Probably means that we have it too lean or there's too much air. So we got to close those air dampers off. When we set these up at the factory, we actually close all the air down, light it, they start to smoke real bad, and then we open up the air to clean it up, you know, to clean our burner up. So your fuel pump's here, motor, primary control, ignition, transformer. The photo eye is on top of this cover. You do have an adjustment for fuel pressure. You shouldn't need to adjust your pressure, but if you ever do, for some reason, if you buy a new fuel pump or whatever, you'll turn it clockwise to turn the pressure up and counterclockwise to turn the pressure down. Now, to adjust the pressure, we suggest that you put a fuel gauge in the system to do that. This burner is designed to set up to run between 100 and 140 psi. We do want you guys to pull the burner out at least yearly and inspect the inside liner. Behind this burner is a stainless steel liner. That's going to prevent our tank from burning out, and it's also you know, helps establish flow for the, you know, a good burn chamber for the burner system. So to inspect that, there's 4 nuts on the back side of the burner. You'll take the nuts off and the burner will come out. You stick a flashlight in there and take a look. Now, if you notice that stainless steel liner is real warped or collapsed, it's time to replace it. You're probably looking at it, again, anywhere from 500 to 1,000 hours, and you'll want to definitely be inspecting that and possibly even be changing that. Now, if you open up that, take that burner out and you stick a flashlight in there and you notice a lot of black soot or carbon, it probably means that we need a new nozzle on the end of the burner. The nozzles are about $12 or $15, so it's a very cheap replacement part. But what that's telling us is that we're not burning all the fuel. So you're getting a good spray, good atomization of fuel, and also a drip because the nozzle has started to wear out. So those are some maintenance things down the road that you want to keep an eye on. Right alongside the burner, you'll see we've got our hydraulic filter. It's just a spin-on type filter. The hydraulic oil is just an all-weather hydraulic oil. There's nothing special about it. You can get it at any local parts store or any oil supplier will have that. We're going to go around to the back of the unit, start going over the controls, and then we'll fire the unit up and show you how everything operates. We're going to go over the operation on the controls, and on the side of the control box there is a operations startup and shutdown procedure. If you follow those startup and shutdown procedures, you won't have any problems with getting things going in the morning. It's a very simple machine to operate. I'm going to go over the controls and the control box and the hydraulic functions on the unit, and then, like I said, we'll fire it up. Now, this unit's unique in the fact that we can fire it without the engine running. If you're going to do that for a long period of time, you do need to put a battery charger on the engine, because the diesel burner does operate off of the 12-volt battery. So you need to make sure that you know, have that battery charger on there, or have the engine running. The engine will maintain the battery if you're going to be firing for a long period of time. But we're going to kind of go over the items in the control box first. The main burner controls are on this side of the control box. Again, very easy to operate. You're going to turn the power switch on, and your controls are going to light up. You can actually hear the burner kick in, the hissing, and it'll pitch. There you can hear it firing. On the thermostats, you've got two thermostats. One's the product temp, one's the heating oil temp. They each have 5 buttons on them. These 3 buttons are for the programming of the thermostat and don't do anything for the burner or the thermostat themselves. The only thing that you guys as operators need to know is the up and down arrow. You've got 2 temperatures on here. One is your high setting, one is your low setting. I'm going to shut this off so we don't run the battery down. But the top temperature is going to be what we're reading, what our temperature is. The bottom one is going to be what we're set at. The green number is going to be our set temperature. So you're just going to run the up and down arrows to your set application temperature. On our heating oil, we want to run 50 to 75 degrees hotter than our product temperature. Now, all the different products have the temperature, the desired temperature on the top of the box or the carton that they come in. So if you're running a 3405 product, most of those temperatures are going to be between 375 and 400 degrees. So you'll set your product temperature at 400 degrees, and you're going to set your heating oil temperature at 450 or 475. So you want to, like I said, you always want to have a differential in your heating oil. Alright, we're going to go over to the other side of the controls here. On this side of the control box, obviously we talked about the thermostats. We've got our main power switch for the heated hose that's just on-off. When you turn it on, you'll hear the engine come under load that's kicking in that big 24-volt alternator. On the next operations here is we've got a pump forward, neutral, and reverse. Then we also have our agitator forward, neutral, and reverse on the switch. Our speed controls for the agitator and the pump are located here. The pump is the top one, the agitator is the bottom one. Down here we've got our pump saver switch, which when we're ready to start pumping, we're going to flip this up to the wand control. That's going to activate the switch on the wand so that the switch on the wand works. It's also a safety device so that we only pressurize the hose and wand when we're ready to applicate material. The last thing in the control box, we've got an hour meter, and you've also got a circuit breaker in there. Like I said, all the startup and shutdown procedures are on the side of the control box. So if you have any questions, you just refer to that. There are also in the manuals that are there. We're going to just kind of go over some of the things on the back of the unit. You've got a manual molasses drain valve for draining the kettle if you're changing to a different spec material, or if you need to clean the tank out, or if you're using manual pour pots, you know, to do some small manual work, you do have the drain. You have a cold fill level for your heat transfer oil. Our diesel burner actually heats up oil, and our oil heats our product, so it's a little different than what you would think. And you'll notice that on your thermostats, your burner is going to come on. Once the oil's up to temperature, the burner is going to shut off. Once the burner shuts off, even though our product's not up to temperature, we're still heating it because we're heating that up with our oil. It's kind of built like a boiler. Our cold fill level, you know, if you change the oil, if you're adding oil to it, there is a dipstick also located up on the top here, but your cold fill levels here. We've got 2 temperature probes here. The bottom temperature probe is your oil, the top one is your product. That's what gives us our temperatures on the thermostats themselves. So that reads the temperature inside the tank. The last thing on the back of this tank is you do have an electric overnight heater. This is gonna aid in your heat up times in the morning. If you plug it in, it's gonna get you in that 150 to 200 degree range, so you're halfway heated up when you get there right away in the morning. Now you can leave the overnight heaters plugged in for a day or 2. We don't suggest anything longer than that, because if you reheat the material, it'll actually start to break down and you can't get it out of the kettle. So it does have a reheat, you know, a heating cycle, heating life on it. You can reheat the product about 4 or 5 times before you need to either add some new material or get that old material out. But the overnight heater, you just plug it into the wall just like you plug in a frost plug heater or plug in an extension cord. Do make sure that you unplug it before you take off, because if you take off, the cord's still hooked. And a lot of times they'll wreck the plug-in on the end of it. So the next thing we're going to go to, we're going to take a little different shot here. We're going to go over the plumbing system on how to operate the hose and wand plumbing. Once you get your product hot, and usually at about 275 degrees, 300 degrees, we can get our agitator going. You can see your agitator spinning here. We're going to fire this thing up here in just a couple minutes and show you how everything runs and operates, and you know, so you can see the agitator turning and where the pump is located. Your pump's located here on the top, and again you can see the chain coupling spinning. Just below the chain coupling there is a packing gland. If you notice material starting to leak out of that packing gland, you take the guard off and just tighten the packing gland up a half a turn, and that'll prevent that from leaking. The last thing we're going to talk about is our plumbing system up here, before we kind of go over the operations of loading and you know, unhanging the wand and things like that. We've got what we call a WPC valve, a wand pressure control. This is going to either divert the flow to the tank or divert the flow to the overhead boom and heated hose system. When this is in the up position, our pump is pumping it forward. Our product's going to be coming up this line, coming around this elbow, going straight back to tank, just recirculating. You'll want to get your pump flow established, and you'll see the thermometer climb when you're pumping the product. Before that, this thermometer won't read any temperature until we're pumping product. So this is going to be giving us our actual temperature of the pumped material. You know, so to establish flow, you're going to, you know, start it up and just dump it right back in the kettle. Once your heated hose and wand and boom is hot, we're going to start to move this valve down, and it's cold because it's got cold asphalt in it, but you'll start to change your pressure with this valve here. When we're all the way in the down position, now our product's going to come up through the pump, through the plumbing, and then up to the wand, and it's not going to recirculate any back to tank. That's going to create pressure to push the material through the wand, hose and wand. When you're operating at full temperatures, you're going to want to run this valve all the way in the down position and control our speed of our pump, or our speed of our flow out of the end of the wand, with the speed of our pump. With this wand control switch in the up position, that pump is going to stop. The only time the pump is going to turn is when we pull the trigger on the wand. Excuse me. When we're getting things established, we're going to actually, we have the ability to stick the wand back inside the tank and establish flow through the wand before we start crack sealing on the roadway. I'm going to unhang the wand now so you can kind of see how we can you know, hang that wand up in here and recirculate the material. We do have a safety latch on the top and a safety latch here. That unlatches the boom. Now this allows us to spin our wand, stick our wand right back inside the kettle to establish flow. Now the switch I was talking about is located right here on the wand. You can hear me click the switch. When that's the wand control switch is in the wand control, the pump will be stopped until we pull the switch. Then the pump's going to start. We let go of the switch, the pump is going to stop. Now the reason we do that is we're only pressurizing the wand when we're applicating material. There's actually, you know, that's a huge safety device, and it also makes your pumps last longer. The pumps just naturally wear out because of the nature of the material that we're pumping. So the less we can turn that pump, the longer it's going to last. So we only want to turn the pump when we're applicating or when we're establishing flow. The trigger does have a trigger lock on the side of it, so you can lock the trigger on the wand. With the overhead boom system, we really want to get you guys working behind the unit. That's really what this is, the whole boom is designed to do. You're going to work from side to side, front to back. This way our truck driver can see us, you know, you can see the operator back here. We don't want you up in here because it's going to put undue strain on that hose and the hose system and the heater and the hose. It's crucial that you don't kink and bend that wand, because to replace the hose and wand, excuse me, you're looking at about $700 to $800. So we want to try to keep the hose, you know, from breaking. And inside that hose, there's actually a heating element. There's 3 heating elements on the system. There's one here in the wand. There's one that goes back through the boom, and then there's one that comes down through the hose. The one that you're going to replace will be the one that's in the hose, just because it's bending and flexing and kinky. So the less kinking we can do, the longer that's going to last. Now, I've got customers that'll go years on a heated hose system, and I've got customers that'll go through, you know, one every 2 months. It just kind of depends on how you take care of your equipment. As long as you don't bend and kink that hose, you know, usually things are pretty good. And when it's hot, this is very flexible. It's cold right now, so it's fairly stiff. When everything's hot, it's much more flexible. Where we see guys breaking elements is right here, because they kink it, or they'll break them up here because they're jerking on the hose trying to get, you know, that last 6 inches of hose out of it. If you run, you know, if the driver pulls too far forward, have them back up. You know, it's just going to save your elements and your hose on it. The hose is equipped with a safety jacket. If in the event that the hose starts to leak, this jacket will fill up. So if you notice that the jacket starts to get holes wore in it, either repair the jacket or replace the jacket. It's fairly inexpensive material to put on the outside of this hose. It also protects our wires. We've got wires that come up to our switch, and also wires that go to our heating elements. And you'll also notice that this has actually got an extra plug on it. This is for an option that you guys didn't receive. Now, you have a swivel between the wand and hose. You just have to be careful that if you set the hose on the ground, the next guy picks it up, he doesn't twist the wires up on the hose. So you want to make sure that, you know, that the hose is always going to swivel, but you just want to make sure that we don't wrap these up tight and pull the plugs apart. All of the wiring on our system is a soldered connection, or it's a weather pack type connection, like what you're seeing here on the wand and hose. So that's kind of your basic operations of the heated hose system. I do want to show you the safety loading chute. And again, guys, if we follow our startup and shutdown procedures, you know, it's very safe. You know, one of the things I always like to talk to guys about, you know, I understand that when we're out crack sealing, it's usually kind of hot. It's a hot tar kettle. You know, we recommend that you wear, you know, pants and work boots, long sleeves. You know, when you're loading the kettle, make sure that you have some type of safety eye protection or a face shield on when you're loading it. Now, this is called a safety loading chute. It's called that because it's safe. We're going to open the cover. You're going to set your block on here, close the cover, splash-free loading. Now, if we open the cover and we chuck blocks in there, it's not splash-free loading anymore. So that's what this is designed for. You set the block on there, close it. If the tank splashes, it's actually going to splash up against the cover and it's not going to burn you. So your shutdown switch is located right here. When we open the cover, that shuts the agitator off, so that you know, the agitator's not going to create a splash when you open the cover. So, you know, this is your shutdown switch here. So you put the block on there, close the cover, splash-free loading. Alright, I'm going to start the engine up, and I'm just going to show you how to operate the pump and agitator. The engine's got a governor on it, so it's going to come up to speed. Like I said before, you turn the key backwards until the glow plug light goes out. Once the glow plug light goes out, we can start our engine. It's going to come up to speed, and we're going to come back and start our we didn't talk about, I'm going to shut things down, and we're going to talk about the shutdown procedure. This is probably the most important part of the kettle. I'm just going to put everything back in neutral, turn our power switch on, and I'm going to just turn the engine on. So you can hear me talk. The one thing we didn't talk a lot about is our shutdown procedure. And again, this is on the side of the control box, the startup and shutdown. When we're pumping things, we've got a good established hot flow material through this plumbing. Now from this point on to the end of the wand, we have a heater in the hose and wand and boom system. This portion of the plumbing does not. So our shutdown at the end of the night is when we're operating, we'll have this valve in the down position, or the number 10. When we're done for the night, we're going to shut this back up to recirculate the tank. We're going to come here, and we're going to turn our pump in the reverse position. Turn our wand control off, or down to the pump saver. And we're going to reverse the pump for anywhere from 60 seconds to 3 minutes. Excuse me. And what we're doing is evacuating this plumbing and getting the material out of the pump. That's just going to help your heat up times tomorrow morning, getting a flow established through there. If you forget to do that, or if someone walks up and turns the key off while everything's running, you're going to have plumbing that's plugged up because it's not inside the tank where it's hot and it doesn't have a heater in it. So if that happens, and sooner or later someone will forget to do that, you do have to warm this portion of the plumbing up with a hand torch. Now you have to be very careful because we got wiring, and you can melt the guts out of the valve. So you know, in the event that you do have a problem, that they forget to reverse the pump, you know, you have to get a torch on the plumbing to thaw that out. But as long as you reverse the pump, you know, 30 seconds to 3 minutes, or excuse me, 60 seconds to 3 minutes, you know, you're not going to have problems with that tomorrow morning. On behalf of all of us at Stepp Manufacturing, we'd like to thank you for your purchase. If you have any questions or need any service help or have service related questions, please feel free to give us a call at 651-674-4491. Our telephone number is also located on the side of the unit and also on the VIN tag on the side of the frame. Again, thank you for your purchase, and we look forward to doing business with you in the future. Thank you.